All right, number 56, y equals 1 plus 2 e to the x minus 3x. We want to find the point where the point of tangency happens here. So let's do this. First of all, the derivative is dy dx. Down the list, the derivative of 1 goes away. It's a constant, it's 0. The derivative of this is, cover up the coefficient, the derivative of e to the x is e to the x. There's still a 2 there. And the derivative of negative 3x is minus 3. There's my derivative right there. Okay, let's solve this for y. Y equals 3x minus 5. If I move the y over and the 5 over. So my slope here is 3. Right? All right. So now if I set these two equal to each other, because parallel, this slope is parallel to this slope, so 2 e to the x minus 3 is equal to 3. So 2 e to the x, add 3 to both sides, is equal to 6. Then divide by 2, e to the x equals 3. So we're going to natural log both sides. And x is equal to the natural log of 3. Okay, so that's the x. Now let's find the y. Okay, so if I substitute this back into the original, then y is equal to 1 plus the natural log of 3 right there. Since they're inverses, I get 3 times 2 is 6. Okay, minus 3 natural log of 3. I'm just going to leave it like that. Okay, I can put those together. And so my ordered pair is this. The natural log of 3, comma, 7 minus 3 natural log of 3. Notice I never used my calculator. I never found out what the natural log of 3 is. You could, and you'd have an irrational decimal going on there, but I never did. So now, didn't ask for this. This is the answer, but they asked us to illustrate this by graphing. So I'm going to write the equation this line. It would be y minus 7 minus 3 natural log of 3 equals, my slope is 3 quantity x minus the natural log of 3. I'm going to put that into this calculator right here. Okay, so all I'm going to do is take this and move it over as a plus right there to be able to put that in my calculator. Okay, I hope I put that in there right. Let's see. If I hit graph, there should be a tangent line parallel to the original tangent line that glances off. Okay, so